everyone, today we're going to take a look at lesson 5-5, solving polynomial equations. So we're going to take a look at some vocabulary. Prime polynomials, meaning we're not going to be able to factor them at all. They are what they are. You can't do anything about them. And then we have quadratic form. So the first thing we're going to take a look at is some factoring techniques. We have sum of two cubes and a difference of two cubes. So these are pretty much, you have a cubed plus b cubed, and it has this pattern of a plus b times a squared minus ab plus b squared. And then in a difference of cubes, it's almost exactly the same thing, except we have a cubed minus b cubed, and then a minus b times a squared plus b plus ab plus b squared. Go ahead and take a moment to write that down as needed. Pause the video whenever you need. So we're going to take a look here at factor the polynomial x cubed minus 400. So using a sum or a difference. In this case, we would look at the word for difference. And the reason we know we're going to look at difference is because we have that minus sign. So this here would tell me that we're going to look at a difference. And so the first thing is, yes, I know x cubed is a perfect cube. However, 400 is not a perfect cube. Therefore, this is a prime polynomial. And I'm not going to be able to factor it. Next, we're going to take a look here using a sum of cubes, and we know it's a sum because we have a plus sign. So we're going to take a look and see if 24x to the 5th plus 3x squared y cubed can be factored. So the first thing we should do here is actually factor out the GCF. What is the greatest common factor? And when we do, we see that they both have 3x squared in common, and we're left with 8x cubed plus y cubed. Now here, we're in luck because both of these are perfect cubes, so we can go ahead and factor these. 8x cubed is a perfect cube of 2x, and y cubed is a perfect cube of y. So that would mean my a value here is 2x, and my b value here is y, if we're looking at the pattern. And with that pattern, I can just go ahead and fill in the information that I have, which would be 2x plus y times 2x squared minus 2xy plus y squared. And we're going to go ahead and simplify that. And by simplifying it, we get 2x plus y times 4x squared minus 2xy plus y squared. But we're not done because we do need to remember to go ahead and make sure we bring back the GCF that we pulled out earlier. So we can say it's the same thing, but we just need to go ahead and add that to it. All right, go ahead and try this, pause this video and try the problem. All right, so looking here, what we have is, I know I'm going to use a sum, the pattern for sum, and then we're going to take a look and see if these have any GCF. And if we look at it, we should see that you can pull out 2x squared from it, and we end up with 27x cubed plus 64x, y cubed is what we end up with. And those are both perfect cubes. And with that, you do factor out into a 2x squared times 3x plus 4y times 9x squared minus 12xy plus 16y squared. All right, go ahead and try this problem. Pause the video to go ahead and try it out. All right, with this, we actually are not able to factor anything. It is prime, and that is because actually, while 64, x to the 9th are perfect cubes, 27 is a perfect cube, y to the 5th is not, so we can't do anything with it, and we're going to leave it alone. All right, go ahead and pause the video. Take time to go ahead and write this down. These are some factoring techniques that are very common that will be used. So to start off with, we have for the number of terms. For any number of terms, you can always factor out the GCF if there is one. It is a number or a term that is, how do I phrase that? It's a common multiple or divisor of all the terms in that expression. If you have two terms, there's three special techniques that we have: a difference of two squares, a sum of two cubes, and a difference of two cubes. We've already gone over sum and difference of two cubes. For a difference of two squares, the pattern is a squared minus b squared equals a plus b times a minus b. And we have run into this a couple times already in class. Next, we have factoring trinomials, and this is the one we generally tend to use more when we look at quadratics. And we have two different types of trinomials. We have perfect square trinomials, meaning it's a plus b squared or a minus c squared. And generally with this, usually the biggest mistake when we're going from the factored form to expanded form is people forget that you need to go ahead and do the box and distribute completely, and instead of just squaring a and b. Most people tend to leave out the middle part. And you have the pattern for where it's a plus b squared and a minus b squared. And then we have our general trinomials. There is a pattern to this, believe it or not. We do practice this from factoring, especially in quadratics. Generally, this would be undoing FOIL, which is what a lot of people did learn. We do step away from that just because FOIL doesn't work past trinomials. And then if we have four or more, we can always do factor by grouping, where you would group the same number of terms in two different sets and pull out what they have in common. And if it works correctly, you should see that you have the same set in the parentheses. And so once the parentheses would be one set and the other, what's in front of them would be your other factor. Again, pause the video to take time to go ahead and write this down. It is very useful to have. All right, so we're going to take a look at this example number 2. Factor the polynomial x cubed plus 5x squared minus 2x minus 10. If the polynomial cannot be factored, write prime. So looking at it, we do have four terms. So we're going to try and look at, first off, if there's a GCF. And I can see that's not going to be the case. So what we're going to go ahead and do is factor by grouping and find the GCF of each group. So we're going to group the first two and last two together and pull out the GCF. So in the first group, our GCF is x squared. In the second group, it is -2. And with that, you should notice that our set of parentheses do match now. So we're going to go ahead, and that is one factor. My other factor comes from what's in front of the parentheses. So our final answer here is x plus 5 times x squared minus 2. Another example we have for factoring by grouping is when we have multivariable grouping. So we have more than one term or more than one variable here. So we're still going to group. Generally, you're going to try and group the variables that they have most in common. So for example, I wouldn't use a squared and 6y cubed together. I would want to make sure I put the y cubed with something that also has a y in it. Same thing with the a squared. You want to make sure you have an a in there for you to factor it out. So in this case, we are going to group a squared and 3ay, and then 2ay squared and 6y cubed, and factor out the GCF, which would be a and 2y squared. And we do notice that our parentheses are the same. So since they are the same, we did factor correctly, and we have a plus 3y times a plus 2y squared. And as a reminder, again, the second factor comes from what's in front of the parentheses. All right, go ahead, pause the video and try out this problem. All right, taking a look here, we would do factor by grouping, and we would group the first two and the second two. Doing that, I would pull out d squared, and I'm left with d plus 2. I would pull out a 4, so plus 4, and I'm left with d plus 2. So the pair would be one set, and then what's in front of the parentheses would be my second set, so d squared plus 4. So my answer is C. There is no factoring technique for a sum of two squares. We only have one for a difference of two squares. All right, go ahead, pause the video to go ahead and try this problem. right, taking a look here, we would group the first two and last two. So r squared plus 4rs I would pull out an r. And I would be left with r plus 4s squared. Over here, I would pull out a 2s. And we would be left with r plus 4s squared. So r plus 4s squared would be 1. Our parentheses match, and then we'd have r plus 2s, which would be b. All right, taking a look here at combining cubes and squares, we have quite a bit going on here. Definitely trying to see probably factoring by grouping and seeing what they have in common. So we're gonna get two groups of 3. So we're gonna notice that these all have the first 3 all have y's in it, and the second group all has z's in it. So we're gonna pull out the GCF. So the GCF is y cubed of the first and z cubed in the second. So with that, our set of parentheses did match. So we have y cubed plus z cubed times x squared minus 3x plus 2. So we have a lot of going on here. Here we have a sum of two cubes. And here we probably have something we can go ahead and factor out this trinomial. So using the pattern, you get y plus z times y squared minus yz plus z squared for the sum of 2 cubes. And so then now we're going to take a look here at x squared minus 3x plus 2. And by factoring it, they do get x minus 2 and x minus 1. So that our final factor is x minus 2, x minus 1 times y plus z times y squared minus yz plus z squared. So you had to do about 3 different types of factoring here. All right, taking a look here, we have 64x to the 6 minus y to the 6. So we're going to have we have both a sum of 2 cubes, a difference of 2 cubes as well as a difference of 2 squares. So when you have both of those happening, you always want to take a difference of 2 squares first. It'll just be easier on you. If you do it the other way around, you have to factor a trinomial in the end, which is not fun. So when we do a difference of 2 squares, we end up with 8x cubed plus y cubed and 8x cubed minus y cubed. So with this, we can now go ahead and do a sum and difference of 2 cubes. So we just follow the pattern that they give us, and it factors everything out that we would need. So 2x plus y times 4x squared minus 2xy plus y squared times 2xy minus y times 4x squared plus 2xy plus y squared. So you're just following the pattern to fill that one out. All right, go ahead and pause the video and give this problem a try and factor the given. All right, taking a look here, when you work it out, you should get B. You would group the first 3 together and the second 3 together. All right, pause the video and go ahead and try this one, 729p to the 6 minus k to the 6. If you are stuck, I do suggest rewinding the video back to the example we did last. All right, when you work it out, you should get A. You would do a difference of 2 squares and then a sum of 2 cubes and a difference of 2 cubes. All right, so here we have our real world example. Determine the dimensions of cubes below if the length of the smaller cube is 1/2 the length of the larger cube and the volume of the shaded figure is 23,625 cubic centimeters. So there's a couple things you need to know is one, what is the formula for volume? is probably the most important thing. And for a cube, it's always the side cube equals volume. So whatever the side length is, you cube it, and that would tell you your volume. So since we have the length of the smaller cube is half the length of the larger one, the lengths can be represented as x and 2x respectively. The volume of the object equals the volume of the larger cube minus the volume of the smaller cube. So if you go back to look at the image, we know the blue shaded portion here, as we can see that we just took a block of it out, is 23,625. So following with what we have, then we know the larger part of the cube is 2x cubed and then minus x cubed. And that would equal 23,625. By using properties of exponents, we simplify it to 8x cubed minus x cubed. And then we can combine like terms and have 7x cubed equals 23,625. We then go ahead and divide. At this point, we have a couple options. We can go ahead and when we subtract, we can go ahead and do difference of 2 cubes. And we can get this pattern. Another option you have is taking the cubic root instead and seeing what we get. And you will go ahead and find by using the zero product property, you get -15, and then you have another 2 imaginary answers. So in this case, we live in the real world, so we're going to take the real answer, which is 15. We would also have to look at it. Remember, in real world, we look at length is only positive. So even though it says the length is -15, it's still a positive 15 for our answer. And that is the size of the smaller cube. So, and then we'll go ahead and multiply that by 2 to get 30 for the side length of the larger cube. You're going to use the same concept here, but the only difference is the cubic centimeters is now at 5,103. So go ahead and pause the video, work it out, and unpause when you're ready to move forward. All right, checking your work, you should get 9 and 18. Again, when you have multiple choice like this, you do have a couple options. You can go ahead and plug it into the formula and see which one works, or working it out by hand. All right, going into quadratic form. So this is just rewriting polynomials in the form of x squared plus x plus c, with your x being a higher degree term. Pause the video, take a note of it, see what you can do. So we have here in our example number 5, 2x to the 6 minus x cubed plus 9. We can go ahead and write this in quadratic form. X to the 6 is the same thing as saying x cubed squared. So one thing you can always check and see is if this exponent here, if multiplied by 2, equals this exponent here. If that is the case, then you can go ahead and write them as quadratic form. If that's not the case, you won't be able to. So pretty much the only difference here is that now it's 2x cubed squared minus x cubed plus 9. Here's the second part of the example. So they want us to go ahead and write in quadratic form. Well, 3 times 2 is 6. That does not equal 4. So that means I cannot write this in quadratic form. All right, go ahead and pause the video and answer this question. All right, this can be written because 5 times 2 is 10. So I'm going to write things in terms of x to the 5th. So we get, I believe, C. All right, pause the video and answer this question. All right, well, working this out, we see that 3 times 2 does not equal 8. So that means my answer is D, cannot be written in quadratic form. So you may be asking, why is this useful? Why should I do this? And part of it's solving polynomials that are of higher degree that we don't have, say, a formula to do or factor easily. Like in this case, x to the 4th minus 29x squared plus 100. If I rewrite this in quadratic form, I can solve it easily compared to, especially if I do not have a calculator to help me out. For graphing, we can go ahead and do this by factoring. So we're going to rewrite this in quadratic form, and we get x squared squared minus 29x squared plus 100. So they're going to let u equal x squared, and so we can just substitute that in. And now we can go ahead and factor. And we get u minus 25 times u minus 4. And we can use zero product property of u equals 25 or u equals 4. So we have x squared either equals 25 or 4, and we can get, solving that, we get plus or minus 5 and plus or minus 2. So we have our 4 solutions of where it would cross the x-axis, which is 5, -5, 2, and -2. So this one's much more helpful if you are comfortable with factoring trinomials. If you're not as comfortable factoring trinomials, it is a little difficult, but this is an option that you do have. Pausing the video to go ahead and try this problem out. All right, with it, you should get A. Your quadratic form that you should get should be x cubed squared minus 35 times x cubed plus 216. So if we let u equal x cubed, we get u squared minus 35u plus 216. And this would factor into, I need two numbers that multiply into 216 that add up to 35. So let's see, 216 is divisible by, what is it, by 3? So you have 1 and 216. You would make a list of your so 2 and 108. So I'm looking for a set that will add up to 35. Four and 54. I know 5 doesn't work. 6 and 36, so that's not going to work. 8 and 27, that one will work. So it's going to be u minus 27, u minus 8. So u equals 27 by the zero product property, and u equals 8. So x cubed equals 27. U cubed equals 8. The cubic root of both of those is 3 and 2. That is the end of our lesson. So I will see you next time when we go over lesson 5-6. Bye.